Hello, everybody. Welcome to Geology. Today, I'd like to talk to you about the nature of science in general. Before we get a kind of unpack what geology is, we're going to talk about science in general. We'll look at how it operates. We'll look at controlled experiences and distinguish between hypothesis, theory, and law. We'll touch on science, religion, and then, of course, get into what geology is all about. So here we go. First off, the nature of science. And really, science is an organized body of knowledge that's been built up and developed over thousands of years by many individuals doing work on this specific thing and that, really putting together a great body of knowledge for us to really stand on the shoulders of the people before us. So we can come into the classroom and learn a lot. That took hundreds and thousands of years to kind of develop as far as solid science knowledge. Science really is a tool for problem solving. We know that it's important to use cause and effect relationships and reasoning and logic in order to try to come to really good conclusions on things that we're deciding and choices we're making, things we're thinking about. Science really provides a way for us to do that in a pretty organized manner. Um, Science gathers and uses experiments and produces data from those experiments. And that data then helps inform us on the answers to some of the questions that we have. And ultimately, science is a way of unlocking the mysteries of nature by asking good questions and seeking out the answer to those questions. That's actually what we call scientific inquiry. That's the process of asking good questions and seeking the answers. And ultimately, and scientific inquiry can be what you would see in yellow there, this process of asking questions, finding the answers, that really flushes out more questions, generates new hypotheses. Oftentimes, we use what we call the scientific method to solve some of these questions and problems. And the scientific method, it's shown here as kind of a linear thing, but it's really a dynamic process that involves lots of different uh, um, adjustments and resets and kind of moving forward. But ultimately really helps produce lots of good data for us to answer our questions. Scientific method is defined as an approach to problem solving based on observations, which we would consider, and predictions, which we can consider the hypotheses. And then the experimentation provides data for us to really give good answers to those questions that we're seeking answers to. Really, in all, what we're able to do with scientific inquiry is wonder about nature, ask questions, use the scientific method to kind of hammer out some of the natural observables and really describe those things that we observe in nature, and then we can kind of use a theory to describe and explain how all those things tie together. So controlled experiments are one important thing that we see in science, and they are really basically just trying to gather good, solid data using a particular method of experimentation. And what we do is typically in a control experiment is you have a control group, which is kind of like the normal situation, and an experimental group, which is the changed situation in some way. The change we make to the two situations, the two groups are identical except for one change. We call that change the independent variable. And then you run the experiment with your two same things with just the one change, and we look at the results then, and the results are called the dependent variable. And through this process we're able to really get some gather some great data to say yes, this hypothesis worked, or no, this hypothesis didn't. Um, and so that's really pretty important. Here's an example of how you would use a controlled experiment. um, you have a distilled water in a beaker, and then you have another beaker with distilled water, and it's boiled just the same, probably using the same amount of water, the same type of water, but the only difference is we add some salt to the second beaker. That salt would be the independent variable. So our two groups, the control group, the beaker of distilled water, the experimental group, the beaker of distilled water with salt in it, and the independent variable of salt. What's the result? Well, when we run the boiling experiment, the dependent variable is scale on the rim for the beaker with salt. And so that provides us good data to draw conclusions moving forward. So control experiments are pretty important in the realm of science. Uh, One thing we also hear in science thrown around are these terms hypothesis, theory, and law. And so I want to kind of get those straight in our heads as we move forward here. So to start with, a hypothesis is a testable, educated guess about how nature operates. And I say testable because you're going to look at something and see, you know, the to see how nature operates and kind of make a statement of how nature operates. But that statement, in order to be a hypothesis, has to be something that's actually testable. Um, Whereas a law is a hypothesis that's been supported by ample data, has been through many tests, and it's really kind of what we would call a natural observable. It's really a description of how nature operates. So, how planets orbit, for example, are part of Kepler's laws, and how objects move and how forces are applied are part of Newton's laws. And these are just a description of how nature operates. And so hypotheses and laws are kind of related to one another very closely. A theory is more of a widely accepted explanation for a set of hypotheses and laws. It really ties the hypotheses and laws together and kind of explains how they all operate and work together. Theories often successfully predict yet unseen and untested natural phenomenon. And really, a theory is only as good as the data supporting it. We don't really ever have all the data, so we're never 100% correct with our theories, but we certainly can be pretty correct, like 90% correct. And then the more data we get and the more data we add, we can become 93% correct, et cetera. But so that's kind of how science works. Sometimes in elementary school, or in primary school, something maybe this message gets muddled a little bit in the delivery or the reception, but sometimes we think it's hypothesis, theory, law. That's not how it really works. Um, Science is more based on being able to test things, gather data to support conclusions, observe the natural world, and then try to explain the natural world through theories. Example on my right here of the slide is plate tectonics. Plate tectonics is a theory in geology, a really grand unifying theory. We're going to talk all about it, but it really illustrates the point very well. This is a good point for me now to make a short explanation of science and religion, and just really distinguish them. Sometimes these get pushed together and or are talked about and discussed as mutually exclusive, or excuse me, conflicting with one another, and they don't necessarily do conflict with one another. In fact, science they seek answers to our natural world in two different ways. Science seeks answers and understanding through the natural world based on gathered data. And science asks the question, how? How do things operate? It's really unable to answer philosophical questions like what's the purpose of life. Whereas religion, this is more concerned with spiritual matters, and this is where we ask the why, looking for meaning through worship and relationship. Um, it also kind of pursues truths, but in a different manner. And so science and religion are actually uh, not conflicting with one another as they're often portrayed to do so. In fact, Albert Einstein here in my quote on the right says, "Science without religion is lame. Religion without science is blind." And a quote from Martin Luther King Jr. here on the bottom: "Science investigates, religion interprets. Science gives man knowledge, which is power. Religion gives man wisdom, which is control. Science deals mainly in facts. Religion deals mainly with values. They're not rivals, they're complementary." So, a couple of wise people out there speaking to this point. Lastly, just want to introduce to you geology. Geology is the study of Earth, Earth's formation, place in the universe, atmospheres, ocean, its history, its structure, surface, materials, processes, resources. This is all part of geology, and so we're going to tackle these topics this semester. Geology really studies how Earth's systems, the main systems of the Earth, the four major spheres, the lithosphere, the hydrosphere, the atmosphere, and the biosphere, how they work together, interact, and affect life and humanity. Geology is subdivided into many fields. There are many types of geologists out there studying, and really these geological fields, they cross curricula and go to different areas. For example, paleontology is a geological study, but it's also a study of life. It's a study of past lives, so paleontology. Hydrogeology is geology studying water, seismology, looking at how earthquake waves go through, oceanography, mineralogy, environmental geology, just to name a few. There's many subsects of geology. I like this picture on the bottom here, kind of like explaining how geology can be mean different things to different people. So you can kind of just enjoy some of the references you might see there in as a geologist. So, can you come up with a couple of reasons? Why should we study geology anyway? Very interesting question. I'm sure that we could probably come up with something. Um, but here's a few ideas. Natural forces do shape and affect our environment. So we live in a world that affects us, and we have to be have a little bit of knowledge of it in order to live synergistically with that environment. We experience volcanoes and earthquakes, power through nature in the atmosphere and severe weather. And of course, we need things. We need things to make our vehicles go, like petroleum, electricity. Um, we need valuable resources, and we, of course, research and development through geological products. These are all necessary things for our life and our society as we know it. We also need to learn how to live synergistically with our environment, as I said before, protecting our environment and really kind of like caring for it and living with our natural world rather than opposed to it or in opposition to it. And then, of course, geology really kind of seeks out answers to our very existence. We'll talk about kind of like we study the history of geology and the history of life as it goes through the rocks. The rocks tell us a lot about how the history has gone and where the Earth eventually or ultimately came from. These give us answers to some of our very ideas of existence. So that's a quick tour of geology. Just want to introduce you to the topic, remind you about what science is, look at how we gather data, and really science is based on data. I'll say that again, it's a really important point. Science is based on data, and so we can't really make claims past the data that we have. Sometimes the name of science gets smeared one way or another from one side of the aisle to the other, and it's really shouldn't be. It's more of a adventure in thought and humanity rather than something to for you know swaying people's ideas this way and that. Science is just based on data. I distinguished hypothesis, theory, and law. I talked about science, religion a little bit, and then what geology is and how we're going to really enjoy studying it this semester. Lots of interesting and neat topics, and I look forward to talking about it with you. So take care, and we'll see you next time.